Hi guys, today we're learning to solve part-whole problems, and in particular we're interested in those problems where we don't know the whole amount. To begin with, I'd like you to consider the following problem and discuss your thoughts with somebody else. Here we've got Yoda and Obi-Wan, and they've both got some money, and Yoda wants to find out how much they've got altogether. Now he's saying that in order to do that you always need to do a sum like this, whereas Obi-Wan's saying that's not true. There are lots of ways to work that out. So what I'd like you to do is discuss your thoughts and decide whether you think it's always, sometimes, or never true that you have to perform a sum just like Yoda's suggesting. So pause the video for a couple of minutes, discuss your thoughts, and remember it's very important that you give reasons and justify why you think that. Okay, so hopefully you've had a chance to share your thoughts on whether you think it's always, sometimes, or never true that Yoda needs to perform this sum. In my own opinion, I don't think we ever need to do that, so I would say it's never true. Yes, we can use that as a strategy, but there are always other strategies we can use in its place, and today we're going to explore just some of those strategies. Okay, so what I'd like you to do now is have a go at investigating a problem with a partner. Here we've got Luke, and he travels 368 light years from the Hoth system to Dagobah to visit Yoda. He then travels 223 light years from Dagobah to Bespin to rescue Han and Leia. And what we want to work out is, how far does Luke travel altogether? So here we've got a part-whole problem where we know the two parts, but we don't know the whole amount. The first part being the 368 light years from Hoth to Dagobah, the second part being the 223 light years from Dagobah to Bespin, and the unknown whole amount is the total distance travelled. I know that some of you may be able to work this out in your head, but the answer here is not the most important thing. What's more important is that you understand how you work it out and you can explain the strategy that you've used. Because if you can do that, you can then apply that strategy to different problems. So what I'd like you and your partner to do is make use of the resources that are available to you, and I want you to use those to solve the problem. And as you're doing it, I'd like you to make drawings, draw diagrams, number lines, anything at all that explains how you worked it out and makes that thinking visible. So pause the video for 5 to 10 minutes and see how many different strategies you can come up with in order to solve this problem. So hopefully you've had a go at that and you've been able to share your strategies with others. Now what I'd like to do is share with you just 3 different ways that I would solve it. There are lots of strategies we can use to solve these problems, but I'm just going to focus on 3 today. Okay, so let's have a look at how we might work that out. I'm going to start by putting out my 368 and my 223, and I'm using the Dean's materials to do that. You could use an alternative resource. For example, you might want to use place value counters. Now, I can't add those two numbers together in one go. So what I'm going to do is I'm going to break those numbers up to make it easier for myself. And I'm going to start by taking the hundreds from each number. I'm going to take that 300 from the 368, the 200 from the 223, and I'm going to add those together to get 500. The next thing I'm going to do is take the 60 and the 20 and I'll add those together to get 80, and then I can take the 8 and the 3 and add those together to get 11. And the last thing I have to do is add those numbers together. So I've got 500 plus 80 plus 11. It might be easier to think of that as 500 plus 80 plus 10 plus 1. And altogether, I get 591. So what we did there was we split the number into smaller parts, and we did that in order to make it easier for us to add them together. And that strategy is called partitioning. Let's try another strategy. Again, I'm going to start with my 368 and my 223 using the resources. But this time, I'm not going to break up both numbers. I'm going to start at one of those numbers and I'm going to add the other number across. Now, once again, I can't do that in one go. I'm going to do that in parts. I'm also going to record how I'm doing that on a number line. And I'm choosing to start at 368. Now the reason I'm starting at 368 in this case is because I think that's going to give me less work to do if I start at the bigger number and add across the smaller number. So from 368, the first thing I might do is add over the 200. So when I add 200 to 368, I've now got 568. Next thing I might do is add over the 20. And once I've done that, I'm now at 588, and there's still 3 left to add across. Now, rather than adding all of that at once, what I might do is add 2 over, and the reason I've done that is because it takes me to a friendly number. It takes me up to 590. And then the last thing I've got to do is add across the 1 to get our answer of 591. Exactly the same as the strategy we used before. Obviously, we've just done that in a different way. This time we started at one of the numbers and we counted on the other number to get our whole amount. We're going to look at one last strategy, and this time what I'm going to do is I'm going to change those numbers. 368 and 223 aren't particularly nice numbers to add together. So what I can do is I can change them, and to begin with I'm going to take one of those hundreds and I'm just going to exchange it for 10 tens. I've still got 223 there, but instead of having 2 hundreds and 2 tens and 3 ones, I've got 100, 12 tens and 3 ones. Now the reason I've done that is because 368 is pretty close to 400. 400 would be a much nicer number to work with. And would I need to add to 368 to get 400? I would need to add 32. So what I can do is I can take 32 from the 223 and I can add it across there, which means I've changed both those numbers. My 368 has become 400 and my 223 has now become 191. And it's much easier for me to add 400 and 191 than it is to add the 368 and 223. So here we transformed the numbers, and we did that in order to get easier numbers to work with. We looked at 3 different strategies there. What I'd like you to do as a class is choose either one of those strategies, or you may want to use a different strategy that perhaps one of your classmates has introduced. And I want you to think about, how do you achieve success using that strategy? What is our success criteria in order that we can solve different problems using that particular strategy? So pause the video for 2 to 3 minutes and have a think about that. And then I'm going to show you what I think are the steps for solving a part-part-whole problem by counting on. When solving any problem, the first thing we need to do is analyse that problem. We need to understand what it is we're being asked in the first place. And to do that, we can use bar models to help us visualise the relationship between the numbers within the problem. So in this particular example, I really did that for you. I drew the bar where you could see that we had a part-part-whole where we knew 2 of the parts. We knew the 368 and the 223, but what we didn't know was the whole amount. We didn't know the total distance. So the next thing we need to do is choose a strategy. Now we can see from that bar that in order to work out the total distance, I'm going to add those numbers together. We can use any strategy we want to do that, and as a class you might want to develop success criteria for a particular strategy. I'm going to focus on counting on. So when counting on, I'm going to start at one of the parts, and I decided to start at the 368 because it's the larger number, and I thought it would be easier to start at the larger number and add on the smaller number. So here's the 368, and the next thing we need to do is count on the other part. And when we did that, I added on 200 to get to 568, then 20 to get to 588, then 2 to get to 590, and then the 1 to get to 591. Now, we didn't count on in ones. We didn't start at 368 and count 369, 370, 371, and so on. That would have taken us quite a while. What we did was we used a strategy that helped us do that more efficiently and more effectively. We used jumps in friendly numbers, or bridging. We jumped to a number and then jumped on to another number. Okay, so what I'd like you to do now is have a go and try that out. You can see here we've got three different sets of questions. We've got mild, spicy, and extra hot. So I want you to solve these using the strategy that you've just developed the success criteria for. Now, when you're choosing a set of questions, have a think about what is going to challenge you. If you think those mild questions are too easy, then have a look at the spicy. If you think the spicy are too easy, have a look at the extra hot. And if you think the extra hot are too easy, then why don't you have a go at making up values that you think will challenge you? Now, as you can see at the moment, we've got part whole problems where we know the two parts, but we don't know the whole amount. But they're not in context. There's just those bars with the values. So what you might find easier to do as you're solving these is put it in a context in order to help. So for example, if I was solving the first of the mild problems, rather than just thinking about that 124 and 143, I'm going to set it in a problem. I'm going to set it in a context. So let's imagine I've got £124 and I get 143 more pounds for my birthday. I want to know how much money have I got altogether. Once you've solved those three problems, what I'd like you to do is make up three problems for somebody else to solve. And it's entirely up to you whether you simply draw the bars with the values, or do you make up word problems that fit with that, that's going to ensure that your partner has to analyse the problem by drawing the bar themselves. Okay, so hopefully you've had a go at those. You've been able to use the strategies that we looked at before. You've used the resources to help solve it, and you've been able to explain exactly how you worked it out so that you understand the strategy that you've used. The next thing I would like you to do is have a think about the following questions and ideally discuss them with a partner. What have you learned today? What did you find easy or difficult? Did you get stuck? What helped you when something got tricky? What do you need more help with? What is really making you think? And what are your next steps? Okay, the last thing I'm going to ask you to do today is apply what you've learned. So as a class, I want you to discuss the following problem and have a go at solving it together. Han goes into a cafe with some money, he spends £9.67 on his lunch, and he leaves with £11.49. So what we want to work out is, how much money did Han have to begin with? Have a think about the strategy that you've been using today. Can you apply that? Can you use the resources? And can you explain exactly how it is you would work this out? Thanks for taking part today. Hopefully you found that useful, and hopefully you've learned something new. You've been able to apply that new strategy. I'm going to be making more videos looking at different skills and different strategies, so hopefully you'll join me next time. Thank you.